Next, we're taking a look at the difference between independent probability and dependent probability. So independent events are two events where the outcome of the first event does not affect the outcome of the second event. So for example, if you're going to roll a die multiple times, whatever shows up on the die the first time does not change what can show up on the die the second time. So those would be independent events. Dependent events are when the outcome does change the possibilities for the next event. So for example, when you're dealing cards from a deck, whatever is dealt to the first person is no longer available to be dealt to the second person. So that changes the probability of what the second person can get. So first we're just going to practice identifying the difference between independent and dependent events. If we spin a spinner over and over, will what we get the first time we spin change what we could get the second time? The answer is no, so these events are independent. Eating M&Ms. When you pull an M out of the bag and you eat it, does that change what you could get the second time you pull an M out of the bag? Yes, so these are dependent events. Dealing cards, we just looked at that example. These are dependent because when you deal a card, what's left changes. Next, we're going to look at calculating probability of independent and dependent events. First, you need to know if the events are independent or not, because that changes how we calculate the probability. So rolling a die and flipping a coin. What shows up on the die does not change what could show up on the coin. So these are independent events, and when you have independent events, you simply multiply their probabilities together. So the probability that you roll a 3 is 1 out of 6, and the probability that you flip heads is 1 out of 2, for a total of 1 out of 12 options. The reason we multiply is thinking back to that fundamental counting principle. If we were to do a tree diagram and list the numbers 1 through 6 and then branch off of each of those heads and tails, there would be 12 different possible outcomes for the two events together. So that's why we're multiplying the probabilities together. Next, we're looking at my husband Josh has 6 nickels and 4 dimes in his pocket. Eli likes to pick up after my husband and charge him for his services. So Josh is going to randomly grab 2 coins to pay Eli for putting away his shoes. What's the probability he pulls out a nickel and then another nickel? Now these are dependent events because what happens on the first pull changes what's left in his pocket to grab for the second coin. So for the first pull, there are 6 nickels out of 10 total coins. We're still going to multiply. Anytime you have and probability, you're going to be multiplying for the same reason as the independent events. But now, after he pulls the nickel out, there are only 5 nickels left in his pocket and only 9 coins left. So basically, the dependent probability just is counting. You just drop whatever is gone from your total options. So we have 30 out of 90, which simplifies to 1/3. And here are a couple of U-try questions for you. First of all, determine if they're independent or dependent events, and then secondly, calculate each probability.